Okay, we want to talk about exception handling. So when something goes wrong in a program and the program crashes, you're in big problems. So we want to put in, let's say, firewalls to ensure that if something goes wrong, you can catch the errors and recover in some way. So it's a reasonably short section. It's not exactly the most important section, stuff you need to know in the short term, especially if you're writing applications to learn C++, but again you need to know about it for completeness. So we need to introduce the following concepts. We have server code, so these are some functions or classes which get called by other classes which are called clients, and in the server something can happen. You get division by 0, or the input is incorrect or something, or you're working in an array and you're outside your bounds and so on, so the things start blowing up and the exception is thrown. So we need to catch the exception in a client block, and because you can get all sorts of exceptions, you need we call it a phishing net. Multiple exceptions can be caught of different types. Okay, so a basic introduction to a real generic term called client-server programming. So we have a client, which is a function, the consumer, and a server is the supplier. So the consumer calls the code in the supplier. So he sends requests. This is like the message passing paradigm. Let me draw a diagram. So here's my server, here's my client. It's all visual now. We'll go to the nitty-gritty in a moment. So you got some code here that this might be some pricer or something to calculate something and whatever. Okay, so let's draw a diagram. The client sends a message to the server by calling one of its interface functions. It gives it the necessary input parameters, of course, integers and doubles. The server checks if the parameters are okay. If the parameters are okay, and if so, we'll compute an answer and give, if everything goes okay, give an answer back to the client. If something goes wrong, the answer is wrong. You cannot trust the answer. In fact, in the current way of doing exception handling, you don't get any answer. So you get an exception object. Okay, but how can the client catch it? Because normally, if you call a function, if something goes wrong in the server, it comes back to the client and you get explosion. So something goes wrong, you get a runtime error, your system stops. Now, in order to accommodate the possibility that exceptions could occur in your program, what we do is we use the try catch block in a moment, but basically the server can throw an exception object of a certain color or a flavor. Where's my pen going? Oh yeah, here we are, up here. Yeah, it's difficult to see. Oh yeah, okay. So what the client does, again as before, it calls the function in the server. Server gives an answer or not, but the server can throw exceptions when the server realizes that there's something gone wrong. So the client can put a catch block here, so it can catch the big fish first of all, or small fish maybe. And you have another net here to catch other kinds of stuff, so that you never get to here, so you never get a runtime error, so that you can catch it and recover. So that's basically what we want to do. There's a contract defined between the parties, the server and the client, because the contract is that the server will execute the results on behalf of the client if the client provides the right parameters. Now, so the contract, it's a statement of how the client should behave. So each of the participating parties has its rights and responsibilities, and if you don't agree by the rules, there's an exceptional situation thrown, and then that's just it. There's no answer, so you have to catch the exceptions. And what is an exception? It's basically an error in the program. So something goes wrong, and you just can't say, "Oh, it's okay, just carry on." You have to do something. And the relationship is that the server knows when the exception occurs, because the server says, well, I can't carry on in this way, there's something wrong. It throws an exception back to the client, who has to take a remedial action. Now, how do I implement contracts in C++? So the client calls a server function. The server checks if the client supplies the good values, etc., etc. If the input is incorrect and we want to throw an exception, what we do is we create an exception object and we throw it back to the client, and the client will catch the exception in order to recover. So what kinds of exceptions can you have in C++? Bad user input mainly. So the range error, you're outside your range, you're in an array of maybe 100 long, and you give the value corresponding to index 120, so you're outside your range. Invalid input should be positive and you give negative values. Numerical errors, overflow, underflow, of course, divided by 0. You can get file access, you're opening something and the file doesn't exist. Domain specific errors in the moment, the bad account, you're trying to do something with the account class we mentioned already and it doesn't work, and memory allocation, etc., etc. Now we'll concentrate. Exceptions are great, but for the course maybe it wouldn't be the top priority, but things like bad user input and numerical errors might be of use, possibly storage errors like file access. But basically when we go to STL, standard template library, it has its own built-in exceptions for underflow, overflow, range error and so on. Actually, domain error here is also important. Okay, so what are the keywords you need to use when employing exception handling in your code? Is the try block, we got a catch block, and we got a throw. So the try block, let me write it here. Where's my pen again? So the try block is in the client, and server. So let me go back to my diagram again. So let me do it visually. So here we're back in my diagram. Okay, it's getting a bit cluttered. The in the code of the client, he does a try. Okay, so you'll see this in a moment. You try some piece of code. When something goes wrong back from the server, we got a number of catch blocks. Catch, C-A-T-C-H, was it? Okay, and the server, he knows that something's gone wrong. The server does a throw. It's all a bit squiggly, but you get the idea, I think. So this is the way you should visualize it. This is the way I visualize it. So the client does a try, goes back into the server checks if there's an exception. If there is, it throws an object of a certain type, of a certain class, and of course the client should have a number of catch blocks to catch the exceptions of each type. So that's basically what we're doing. So what can you throw? You can throw integers, -1, help, strings, whatever. So you don't have to create your own exception object classes. You can just throw numbers. The client block has a try and catch, of course, and the client block calls the server. So here is a server function. So somewhere you will have clients accessing the withdraw function of the account class, which we mentioned already. So you want to withdraw some money. So your balance, m_balance, is the amount of money in your account. So when you're trying to, the precondition is if the amount is greater than the balance, you're not allowed to take money out of the bank if you don't have it. I throw -1, so no funds error code. And at the end, I decrement my my balance. So the balance is decremented by the amount. So that's okay. So if the amount is less than or equal to the balance, you can withdraw the amount. Right? So you're okay. So that's the server function. You see the keyword throw. He throws a -1, which is an integer. So in a moment you will see that the what you're catching is it's like catching fish. Your client block for catching will have to catch an integer. So the client side as I've said, you identify a block, create a block, and we use the keyword try. So here is first of all my try block. So you're trying something within your block. So I create an account here. So the try block starts here and ends here. The try block is account number here and the amount of money in the beginning. So when you withdraw 250 euro or dollar or whatever, the first time it goes okay, but the second time it doesn't, because you're up to 550. So there's in the body of the withdraw function, it gets to here, it gets to here, it throws a -1 because you don't have enough money. So the catch block, you need a corresponding catch block to handle all the errors. You can catch different objects, different kinds of fish. In this particular case we're working with data types. You can catch integers, and the block of code does something. You can catch character pointers and strings and so on. And eventually you can catch everything that hasn't been caught already. You can do catch ... It's a catch all. So you really catch everything. So if I go back to my diagram, where are we? Oh, sorry. Here we are. So we got a number of catch blocks here. It's like a sort of imaginal line or something. So we've got one catch at the very end. If everything fails, I have my final catch. So it's catch ... You see? So this one here catches integers, the next one catches strings, next one catches my user defined whatever errors, STL errors and so on, and the final one is catch ... if all else fails. Okay, so let's carry on with the code review. So here we are in the particular case here again, just what I've been talking about. So here again my try block, of course. The corresponding catch blocks are, he looks first of all for the error integer. So if it's an integer is -1, yeah, not enough funds available, you see. So this one is presumably thrown. And then if some other exception occurs, ... I catch everything. So somewhere an unhandled exception has occurred. So it's really bad news. So what happens when an exception occurs in the try block? The program searches for a matching handler, as I've said. If no handler is found, the stack is unwound to the point of call, and the program control transferred to the handler. And if no handler is found, there's a terminate function called, and that's the end of the story. You get a runtime error. If no exceptions are thrown, so if everything works okay, like here for example, let's say you had enough money, let's say you had 600 in the balance, you would not get an exception here. So these catch blocks will not be executed. So you just carry on beyond the catch blocks. It is so that only one catch is executed at any one moment in time. You won't have the code of the first catch and the code of the second catch being executed. It's only one. Okay, we can create an exception hierarchy. I'm not exactly sure if I should handle it now, because you can read the slideshows and so on, but you can create, you can catch polymorphic exceptions. So here for example, a derived class of an exception base class, no funds instead of a -1, and maybe if we just skip it here because it's maybe it's not so interesting. Okay, so I would just like to stop here. We've done the basic exception handling, and we see the exception handling when we get to STL. So I've skipped this part of the course because I really don't expect you to create your own exception classes. It's a bit overkill, I think, at the moment. Now, in C++, what's supported? Synchronous exceptions. In other words, when you call a member function, something goes wrong, you throw an exception. So all the faults are software faults and not hardware faults. So if I do a Control-C or I pull the cable out of my computer, it's not so the exception handling is going to handle it. These are not synchronous errors. So if we're using, we'll show some examples later on. So it's As I've said, I'm giving you a hint. It's not the most critical at the moment. Concentrate on user logic errors. If you want to check your errors and enforce exception handling, do the logic errors, invalid input type of stuff, domain errors. And as I've said, it's not necessary to find your own exception hierarchies for this particular course. It's a trade-off between robustness and efficiency. All the code you have to write makes your code very robust, but if it's the most efficient in time or space or just for yourself, it's the question. And basically put the try-catch blocks as strategic points only. I usually do it in my main program if I'm doing it for logic errors, when I'm visualizing matrices and so in Excel, for example, but I hardly ever use it in that sense. Okay, so we gave an introduction to C++ exception handling. It's useful to know. So especially the try, catch, block and throw mechanisms. You could skip it to a certain extent without loss of continuity. And as I've said, the exceptions, you'll need to know what exceptions are. The exception is already made in STL. It's got an exception hierarchy, so that's why we're postponing it till later. And the Boost libraries have their own exceptions. So when something goes wrong, you just catch the exceptions which the Boost functions throw. Right? What is the alternative to exception handling? A lot of C programmers are doing it, have done it. The error numbers. You work with error numbers and Boolean stuff. So that's it's also a pain, but it's an improvement, right? It's always a big discussion point. Some people don't like using exception handling because it's inefficient, etc., etc. Quiz: what are the most common exceptions that you encounter in your code? Just think about it. What are the things which go wrong in your code which really annoy you, and how would exception handling help? What happens if an exception is thrown at runtime for which there is no corresponding catch block or handler? If you were it's difficult to say yet, but when you're developing applications, how would you employ exception handling? When would you do it? What's the strategy? What kinds of exception would you want to check, and which would you not check? And what's catch? Okay, that's a catch question. Okay, so that we're basically finished now with the C++ object-oriented part of the course. And the exceptions, to use exceptions, you need to know what the exception hierarchies are and the syntax. Okay, so we'll take a break now. Bye.